Hey everyone, welcome to this video on enabling secure application resource access. I have some application running in a compute resource in Azure and it wants to access another resource in Azure, maybe a storage account, maybe a database. So my goal is to really walk through what are my options. So we're going to look at firstly, what are the resources? What are the roles? What is role-based access control that will affect this? Then, how can I avoid using a secret, a credential? So we'll look at using managed identities. So I don't have to store some master key. I don't have to store some username and password in a configuration file that ends up on GitHub. I can actually let the resource in Azure itself have an identity that I can only use from that resource. Then how do we think about handling services that do use keys, that don't support role-based access control with Azure AD? How I can actually use Azure Key Vault? And then a really quick word on thinking about certificates in Azure. So firstly, resources and their permissions. So the Azure Resource Manager has a standard model for access control. I have these resource providers, and the resource providers define resources. Now, if I jump over to my subscription, if I scroll down, I can see the resource providers. So these are all of the ones that are registered. And then as I scroll down, I'll see ones that aren't registered. And ordinarily, if I deploy something from the portal, for example, it will automatically register the right provider I need that defines the actual resources I'm going to use. For example, the Microsoft.compute, well, that has virtual machines, it has virtual machine scale sets, it has disk images, etc. Now, with each of those resources, they support a certain set of actions. Now, some of them are fairly generic. For example, I can read a resource, I can update a resource. But then there will be resource-specific types of actions. And we create roles that have those actions defined. There are a lot of them built in, or I can actually go ahead and create my own custom role. So if I jump back again, if I scroll up to my access control, I can look at the roles that exist in this subscription. And we see there's a lot of roles, all these built-in roles. Now we'll also see if I scroll down, I have a custom role that I created. Now if I look at a very generic role, let's say contributor. So this impacts basically every type of resource provider. So if I look at its permissions, we can see all the different resource providers. And if I pick one of those, let's go ahead and look at Microsoft Compute. Then I can see all of the different resource types that are defined in that resource provider. So I can see availability sets, I can see galleries, I can see disks, host groups, virtual machine scale sets, and then virtual machines. And we have these kind of read, write, delete, and then other. So if I select virtual machines, now I can see the other actions, all of these different things that I could define. So his contributor role, well, it has pretty much all of them. If I was to look at something more specific, for example, one of the virtual machine roles, let's look at virtual machine operator. There's a custom one I created, so it only has permissions on a subset of the resource providers. And then under the compute, well here, if I look at, for example, virtual machines, it doesn't have all of those actions. It can restart a VM and start a VM, but it can't capture a VM, deallocate, etc. So we have roles that define a certain set of actions across a certain number of resource providers. And then what we do is we grant a role to a security principal from the associated Azure AD instance of the subscription. So each subscription is trusting a particular Azure AD instance. I can only link a subscription to one Azure AD. In your company, it's probably going to be your corporate Azure AD instance. So I can grant a role to a security principal, it could be a user, but better off is using a group that contains users. And then I grant that role to that security principal at a certain scope, i.e., what does it impact? It could be a management group, which is an entire hierarchy. It could be at a subscription level. It could be at a resource group. It could even be at an individual resource, but we try and stay away from that because honestly, that gets a little bit messy. But that's the idea. I have a role, I grant it to something, and that role applies to a certain scope. So the resources I care about would live within that scope. Very commonly, it's going to be a resource group. Now, here's the problem. Often the consumer of a resource in Azure is another resource. I have an application running in a virtual machine, a container, an app instance, and it wants to go and access some maybe data resource, a storage account, Cosmos DB, MySQL, whatever. And so that application has to authenticate to the resource so it can then, through that authentication, check the RBAC and get certain authorization to use that data resource. Well, that would require the application instance to store a credential or key in its configuration. And that would then end up on GitHub. And that's what we call a career limiting event. So here is just kind of in pictures, I have a compute resource. You could imagine this as just an app running in a VM at a really simple level. And it wants to access a data resource. Again, could be a storage account. So the compute resource says, hey, I want access, please. It's the program running in that VM. But it has no credential. It has no one it can act as. So it says, no, you can't access me. Okay. So now I'm going to have a secret. For example, this could be the storage access key if this was a storage account. It could be the master key if it was Cosmos DB. It could be a username and password. Whatever that is, I'm now storing it within some configuration file. The application would read that in and use it as part of the connection. So great, now it has access. But I'm now storing a secret in a configuration file. And that's a horrible thing because we're big on repositories today. We have change control. These are fantastic. GitHub, whatever we leverage, and we go check it in. Now, if we're lucky and we checked it in, it's in a private repository. If we're unlucky, we've just uploaded some master key to the internet where everyone can view it. So how do we get away from having to store a secret? And let's say, for example, it's a credential initially. That application service, that data, supports Azure AD, role-based access control. And so a managed identity provides an Azure compute service to have an identity that's hosted in Azure AD. So just like a regular security principal, you can think of it like a user, but it's for that service and only that service can use it. So then that identity could actually be granted access to resources. Now there are two types. There is system assigned. So with system assigned, it's just automatically managed by Azure. When I turn on managed identity for this service, it's going to automatically go and create that managed identity in Azure AD, and its life cycle is tied to the resource. If I deleted the resource, so too the managed identity is deleted as well. So that's a one-to-one. I can't use that system assigned managed identity from a different resource. Then it's also user assigned. Now this is its own resource. It's its own life cycle. I create a managed identity and then I assign it to one or more compute resources. So it's completely separate life cycle. I'd have to manually go and delete that user assigned managed identity when I no longer want it. So now what happens is the Azure resource running inside, so that application inside that particular compute resource, requests a token to a special endpoint, and it will get a token back as that managed identity. It can then use that to authenticate to other Azure resources. Now, I can use that across subscriptions, providing those subscriptions all trust the same Azure AD tenant. Now, if a resource has a system assigned managed identity and one or more user assigned, if you don't specify which identity you want to use when you request the token to the special endpoint, it's going to use the system assigned. If I don't have a system assigned and I just have one user assigned, then if I don't specify one, it will give me the token for that user assigned. If I do not have a system assigned and I have more than one user assigned, I have to tell it which user assigned managed identity I want a token for as part of the request. So let's kind of see this in action. So I can think about, hey, I've got a VM, there's a storage account I want to access, and then there's Azure AD. So I'm going to go ahead and enable a system assigned managed identity. I don't need a user assigned. User assigned would be useful. Maybe I have some VM scale set. I have multiple instances that are doing the same thing. And rather than having to create 10 different system assigned managed identities, and yes, they get created automatically, but then I have to go and give each of them individually permission to all the different data resources or whatever. If I use user assigned, I can give all 10 of those compute resources that are doing the same thing and need the same access, the same user assigned managed identity, and I just have to set the RBAC on the target resources once for that identity. So I enable the system assigned managed identity. So now there's an object for that Azure Compute resource. Now on the storage account, I would use regular RBAC and give it rights. So for that managed identity, I say, hey, you have storage blob data contributor. So Azure Blob now supports role-based access control using Azure AD on containers, for example. So I can actually use Azure AD for that authentication and to grant different levels of access. In this case, I could read and write. Now, the process inside the virtual machine requests a token. So the application is in that VM1. It can go to a special endpoint and say, hey, I need a token, please, as my managed identity. That token is created. It's going to send it back to me. And now I have that token. So remember, I can only get that token if I'm running within that compute resource instance. I cannot act on behalf of VM1 if I was running in VM2, for example. If I want the same identity across multiple VMs, I would use user assigned. Now I have that token. I'm going to say, hey, storage account, I want the data, please. Here's my token. That's going to authenticate me. And now I'll be authorized for whatever rights that identity has. In this case, yes, I can go and get the data. Let's take a look at this. Here, I'm going to use virtual machines, but there are many other types of resource that actually support this managed identity. Pretty much all of the core compute resources support managed identity. It gives me that Azure AD object, which can then be granted using RBAC to all of the other types of resource. See, here I've got my Windows 10 virtual machine. That's the one I'm actually using for this presentation. If I go and look at identity, we can see I've turned on my system assigned managed identity. I have an object ID. So now that will actually show up in Azure AD and can be given access to stuff. I can even see the roles that have actually been assigned to me already. Now I've gone ahead and set these up. You can see I've got access to a storage account, and I've also got a key vault. I'm going to use these in a demonstration later on. I could also add one or more user assigned. So this is where I could go and add a user assigned managed identity that this would be able to request a token for. Now on the actual resource end, if I look at my storage account, if I just go to the storage account I'm going to use, if I go and look at my access control, my role assignments, you can see, hey look, there is that virtual machine and I've given it that certain permission. If I wanted to add one, I just click Add, Role Assignment. Now when it says Assign Access To, I would select, hey look, it's a System Assigned Managed Identity. You can see those core compute services that can have a managed identity enabled. Or I could select User Assigned. If I select VM, it's going to show me all of the virtual machines that have a managed identity. And that's all there is to it. So I've now given this compute resource the right of storage blob data contributor. Now within this storage account, if I go and look at my containers, and again, I could have set this permission at a container level. There's other things I could have done. I have this imaging container, and I've got a single file within there. Now to demonstrate this, I have a folder test that is empty. And what I'm going to do is I'm actually going to, for the first demonstration, just use the AZ module. This is the latest Azure module I'm going to use with Azure Resource Manager. And I'm connecting with Dash Identity. Dash Identity says connect as the managed identity of this compute resource. So I don't have to pass it a credential. It's just going to connect as this managed identity. It's going to go and check, well, look, who am I? It's going to get the token. So I've got this MSI, that's my managed identity. I'm now going to create a storage context to that storage account using my connected account, i.e. the managed identity. Now I'm going to go to that images container and request the file. I'm going to store it in my test folder. So if I execute this command, that's it. That shows that managed identity working. And sure enough, there's my file. And there's my dog waiting to eat his hamburger and fries. I don't let him eat the fries, don't worry. I'm not a terrible owner. But that's the managed identity in action. And again, I could use a REST API. There's all different ways I can use that. But I didn't pass any credentials. I didn't store any credentials. Nowhere in this script is it looking anything up. I'm running inside that compute resource. And because I'm inside that compute resource, I can request, hey, I want a token as the compute resource because I'm running inside it. Then I can use that token. So it really is super powerful. So that's using the AZ module. Now let's carry on. But I'm going to show you another demonstration in a second, actually using a web request, actually getting the token directly and then passing that. And that's going to be by interacting with Key Vault. But first, what if a data access platform requires a key? It doesn't support role-based access control. I have to connect with a master key, an access key, a storage token, something. So does that mean I have to store that token? So if I can't use RBAC, if I have to use a key, there is another option besides storing the key. Pretty much every service will support role-based access control at the resource level to actually request the key. For example, with a storage account, I can request the access key. If it's Cosmos DB, I can request the master key. So instead of storing that key somewhere, what I can do is give the managed identity of the compute resource that's going to access that storage or that database, whatever it is, give it the RBAC right to request the key. So now I don't have to store the key. Instead, I just say, hey, look, this compute resource has the right to request the key. So then the application would go ahead and get the managed identity token, connect to the target service, request the key, and then connect using the key to the data plane to get the data. For example, this is very common with Cosmos DB. Cosmos DB has a master key. I can't do Azure AD RBAC on the database itself. And typically a Cosmos database is per application. It's not shared across apps. So there's really nothing wrong with getting a master key for the app, and then it can leverage that. So that's a different approach. So always consider that first. Just because it uses a key doesn't mean I have to access and store that key. I can just request the key using my identity. Now let's say there is a secret and I have to store it. So Azure Key Vault provides hardware-backed secure storage of keys and secrets. Now I talked about having to store a credential or a key in a configuration file, and you might say, Key Vault, that's the answer. Why was you talking about a configuration file? You can store Azure Key Vault any kind of secret, not the configuration file, you say. Yes, I respond. But how does the app authenticate to Azure Key Vault to read the secret? It's a chicken and egg problem. Yes, I can store secrets in Key Vault. Yes, I can store keys in Key Vault. How do I authenticate from the app to read it from Key Vault? I'd have to store another credential to authenticate, which kind of breaks the point. And that's the idea of the managed identity. Even if I have to store a secret, if I have to store a key, I can put that in Key Vault and then use the managed identity to authenticate and be authorized to read those things from the Key Vault. So I never have to store anything in some kind of configuration file of the resource. So let's take a quick look at that. So here I have my Key Vault. If I go and look at the Key Vault, there's different types of data that I'll talk about in a second, but I'm going to focus on secrets. I have a secret in here. It's not a very good secret. It's called test secret. And what I do is to control the access in Key Vault, I have an access policy. Now today, that access policy is by the type of data, i.e. is it keys, is it secrets, is it certificates, but it applies to all instances of them. There is no instance level. I can't set different permissions for secret 1 than secret 2, for example. So when I create an access policy, it's going to apply to all of the instances of that type, be it key, secret, or certificate. So I can give it different permissions. There are templates, for example, secret management will automatically give me the key types of action I want to perform on secrets. And what I've done here is you can actually see I've given that managed identity of my VM permissions on secrets. So it's going to apply to all secrets in this Key Vault. But from that virtual machine, I should be able to read the secrets. So if I jump over to my demo again, what I'm going to do this time is rather than using commandlets, which I could absolutely do very easily, I could just do a get AZ Key Vault secret and read it. But to show you the endpoint explicitly, I'm actually going to go ahead and invoke a web request to the endpoint for this virtual machine, and it's standard across all of them. It's always 169.254, 169.254. And I'm saying, hey, look, I want to access vault.azure.net. And my method is get. And in the header, I'm just setting the metadata to true. So I can run this command. And now I've got a response. Next, from that response, I'm going to convert the content from JSON. And now I'm going to get a token that's stored within that response, within that content. So I actually have my token that I got from that endpoint. That is the token for my managed identity. And now I'm going to invoke another web request to the endpoint of my Key Vault. I'm going to pass it that token as my bearer token. And I'm going to ask it for the content. So I'm saying, hey, I want the content of my test secret. It's of type secrets from this particular Key Vault. So if I execute that, we can see there's the value, don't tell. Not super exciting, but that was me accessing the secret as the managed identity. So it's seeing those things work together. So if I had to store a secret, if I had to store a key, and I want to use the key, I can use the managed identity. I can give it permissions through those access policies. If I want to get a secret, I can do it using the managed identity. Just a note, if I am using these access policies, if I want to be able to use it for like VM deployment, if I want to use it from ARM templates or ADE, I have to check the boxes to enable those types of actions to use the key vault. It's just make sure you've done that. Or for example, if I'm trying to use a secret from a key vault as part of an ARM template deployment, a reference to the secret, it would fail unless I've checked the box for Azure Resource Manager for template deployment. So a quick word on those types of data. There are secrets. A secret is something that I can write into the key vault and I can read it back out. Password would be a great example of that. It could be a master key for Cosmos DB. It could be an access key for a storage account. It's something I can read the value back out of the vault. Then we have keys. Now, this is a cryptographic key. I cannot read it back from the vault, but I can perform cryptographic operations in the vault using the key. So if I wanted to sign something, the key has been stored in the key vault, and then whatever operation I wanted to perform, I would send the operation request to the vault that has the key. It would do that cryptographic action and then send me the response, i.e. a signature, the encrypted data. Then we have certificates. This could be a TLS certificate with the public and private key. It does the management, and that's a big deal. It will actually go and integrate with third-party CAs. It will manage the life cycle of the certificate. So I'm going to think about secrets, something I can read back, key, something I want to do cryptographic actions against and let the vault do it for me, but I can't read the key out of it, and then certificate management. As I showed you, there are access policies at the vault level. It is not instance level, object level today. If I have different groups of resources, people that should have access to different secrets, for example, well, then I need to have different key vaults for each particular group of secrets of keys that any unique group of people should have access to. So if I had at group 1, who should be accessing secrets 1, 2, and 3, then an app group 2 that should have access to secrets 4, 5, 6, I need to put those secrets 1, 2, 3, and then 4, 5, 6 in 2 different key vaults. Finally, certificates. Certificates are commonly used for things like SSL, but I can use them for other things as well. And really the only point I wanted to touch on here is that each service in Azure has different capabilities around this. For example, I can use certificates for custom DNS names. I can use them within an application. And if I use a custom DNS name, yes, I can bring my own certificate. But Azure will actually also provide a certificate for your custom DNS name, enabling things like TLS access. So as long as I've validated that domain in Azure, I've added it as a custom domain, I've set up that alias, whatever I need, I can actually go in and use an app service managed certificate, and it will give me that for free. So even though it's a custom DNS name, Azure can still provide me the certificate so I can enable TLS for my app behind that custom DNS name at no cost. Azure Key Vault certificate management can actually integrate with third-party CAs. So if I'm using someone like DigiCert or GlobalSign, it will actually hook into those and handle the request for the certificate and then storing it. If I want to use a different CA, then the Key Vault would create that cert signing request, the CSR, and then the application or you would have to go and pass that request to the CA and then kind of store the response. So that was just really a quick overview of handling kind of secure access. The managed identity is huge. Use that first. The best secret is one I don't have to store. So if I can use managed identity and RBAC, that's what you will use. If I have to store a key, if I have to store some sort of secret, put it in Key Vault and then use the managed identity to get access to that. If there's nothing else I can do, if I can't RBAC to actually go and fetch the key directly from whatever service there is. And then we have this great certificate capability. So I hope that was useful. Please like, subscribe, comment, share, and I'll see you on another video soon. Take care.